My warriors of 11th and 12th standard, welcome to the one-shot revision session with PYQs with me, Shreyas, your physics master teacher at Vedantu. Hello Aishwarya, hi Renuga, hi Saja, Ninja JEE, hello Cholan, Shabana, hi Shivram. Good evening, my lovely warriors. And in today's session, we are going to, not only revise the theory, but also see a lot of problems. And that's what the sprint series is all about, where, we are not only going to make sure that you understand, revise the theory, but also get to know how to apply those concepts in real life problems. And those of you who do not know me, my name is Shreyas, and I am the physics master teacher, and I have been training and teaching for a very long time. Even before Vedantu, I was in all the big names that you can think of in offline, and then I have come over here to make sure on YouTube you guys get quality education in English medium on this very exclusive channel, JEE Enthuse. So do not forget to hit the like and the subscribe button. And this is the flow of today's class. Theory revision, okay? Quick glance of all the important formulas, concepts, graphs, etc. Problems practiced with PYQ. Okay, so get ready to start the class. Hello Shubham, hi Abhishek, nice to see you. So the NEET 2022 exam will probably happen somewhere in June end or July, somewhere around that time, June, July time. Okay, I'm so glad Akshaya, physics has become easy for you. So continue this and keep growing. Yes, I'm very good Aishwarya, thank you so much. I hope everything is going fine with you. Hi Sai Teja, Captain Cool, and cool students of Captain Shreyas. Okay, so very good Sasang if you have dealt with this chapter, and obviously this is going to be very useful. And let me tell you that there are detailed classes of SHM available on YouTube on our channel as well. Go to Nurture series playlist on this channel. You will see SHM lecture and so many lectures, detailed classes as well. Okay, let's get going. Hi Tanaya, nice to see so many newcomers, so many new warriors. And some of you might be feeling shy to chat. Don't hesitate. All of you are, my students, and you guys can mingle around, make friends, and obviously grow together and also crack JEE together. So there are some interesting things. This year we had so many selections, not just in mains but also in advanced. But the bigger news now is NTSC, which is like a mini Olympiad exam for the lower grade 10th students. And this year, this time, in the stage 2 of NTSC, 12.5% of the national selections were from Vedantu. And 1 in 4 students who were enrolled in Vedantu cleared this NTSC mini Olympiad exam. And look at all our lovely toppers, lovely students who have made us proud. So Vedantu is not just about JEE or JEE Advanced. Take any field, be it NTSC, be it boards, be it CET, be it BITSAT, be it NEET, be it JEE Mains, be it JEE Advanced. You are going to see this wall of fame. And you know what this proves? It proves that you can sit at home, use your laptop and crack JEE. Don't have to go anywhere, because you will get the best teachers in the country right at your fingertips. Yes, Shivram, if you want, you can change the batch before and ahead. Yep, you can just send in a mail to vcare@vedantu.com. Hi, Roshni. Tomorrow is your physics exam, Shrikant. Obviously, this will help you. Study only from scratch if you want to learn. Like I told you, there is a detailed playlist of Simple Harmonic Motion, basically Nurture series. Nurture is for 11th. Watch those detailed classes right from scratch if you want to go about it. Okay, today will be more like a revision. Sprint series is for revision. All right. Okay, so you will get some idea about the chapter, but obviously in detail you need to go through the detailed classes. Else, you can complete the entire JEE syllabus in one day. You can watch all 5-minute, 10-minute, 20-minute videos, and that's it, done. Correct. Okay, so we all know what periodic motion is. A motion which repeats itself again and again. And we also know what oscillatory motion is. A motion which is to and fro. A motion which is to and fro. Like I keep walking back and forth in the class, that's an oscillatory motion. So simple harmonic motion, okay, so simple harmonic motion is a motion where it is oscillatory as well as it is periodic. That means it is to and fro motion, and the motion repeats itself after fixed intervals of time, which we call it as the time period. And the motion of that particle, that motion of the particle is represented as a function of time. Because think about it, imagine you have a particle, and it is moving back and forth like this. It is performing a simple harmonic motion. Then that particle's location, let's say that particle is over here at some time t, the x coordinate of that particle, assuming, let's say this is your origin, this x coordinate will change with time. When time changes, x will change. And because it is going back and forth, it has to be some function like sine or cosine. Correct? Okay. So, Renuga, I'm not sure about that. Please leave a comment after the session is over. I'll definitely help you out. Okay. Yes, Shivarama, I'll be teaching, but in the batches which are coming later on. Okay. So, hold on for that time. Till that time, you can watch the regular classes, Shivaram. Okay. Great. Now, Ganga, obviously it will be different, but the teachers are similar, the level of teaching is also very similar. The kind of interaction that you see is obviously much better on the platform, but you get a sense of how our platform will be. But yes, it won't be exactly the same thing what we are teaching here. In the paid platform, you have many more things that are happening, obviously. Okay, having said this, a sine function or a cosine function, remember, how does the graph of a sine or a cosine function look like? It is a repetitive graph. Hence, x as a function of time is also like a repetitive graph, like a sine or a cosine. These terms, what are these terms called as? If you may recollect, this is nothing but your amplitude. This is your amplitude. It tells you what's the maximum displacement from the origin, which is also the mean position. Okay, let's write down these terms. This origin over here is also called as the mean position. Mean means average. It is also equilibrium. It's as good as saying it is equilibrium position. These 2 points on the left and right. Yes, Ankit, I have already made an announcement on our channel. Have a look at it. The KVPR dates I have already announced in that short video which I just made. This point and this point, what are they called? They are called as your extreme points. They are called as your extreme points. Correct? These are your extreme points. And amplitude obviously is from the mean to the extreme. So this much length is basically your amplitude. Or even this much length is also your amplitude. Fair enough. Omega, what is omega? Omega is called as your angular frequency. I'm so sorry guys, there is a ghost which is there in my board. So that ghost is of a wall clock, an old clock. So sometimes it comes and it goes off. Okay, so please don't get scared of that ghost which occasionally is coming. Okay, so I need to do some kind of exorcism or something. I don't know. My board is like haunted, and the board is haunted with a ghost of a wall clock. That's crazy. Oh, anyways, so this is angular frequency. The unit is always radian per second. Correcto? Great. And the relationship between omega and the SHM is that if it is very fast, if it is vibrating, if it is oscillating back and forth very fast, omega is higher. That's what it is. Correct. Yes, we are going to have some PYQs also. Okay. And phi, what is phi? Phi is called as the phase angle. So this is called as the phase angle. Great. Moving on to the next thing. All right. Everybody clear till this point, my warriors? Excellent. Next, the amplitude and the frequency tell you the extent. Like you can see in this graph, this is the graphical way of representing the SHM. I just wanted to get a feel of that. This is a spring mass system. It is going back and forth. You can see this point and that point. Those are the extreme points where I'm pointing here and here. Those are the extreme points. This is somewhere where the equilibrium position is. And this is how the sine graph looks like. This is showing the current state of the particle. It goes back and forth. The coordinate changes between these two extremities. This is a graphical way of showing it. This is a physical system. Now, if you know the position, you can find the velocity, acceleration, and so many other things about the particle. So say for example, x is, a sine omega t plus phi. If x is a sine omega t plus phi, then the velocity of the particle, what is the velocity of the particle, my warriors? The velocity will be a omega cos omega t plus phi. This is one formula. And similarly, acceleration can be written down as a omega square. Do not forget the minus sign over there. And here you will have sine of omega t plus phi, obviously. This is one way of writing it. Yes, Sugneshwar, please use those hashtags on Twitter, on your social media handles, be it Facebook or Instagram. Let's flood it so that it comes into notice and our voices are heard. And please share it with your friends too, that video. Now there is another way. There is another way of writing these things. And that is not in function of time, but as a function of x. So there is another formula which you must remember. Velocity is also omega root of a square minus x square. Keep this in mind. Also, similarly, acceleration is minus omega square into x. So a as a function of x, velocity as a function of x. Here velocity as a function of time, acceleration as a function of time. Thermocholan is already taught. I have taught it in detail in my nurture classes. Please check out the previous videos and the past playlist. It's there, okay? Recently only it was completed. Also remember one more thing. This a omega happens to be the max amount of velocity or speed if you take the magnitude, and a omega square is obviously the max magnitude of the acceleration. This is a max acceleration, this is maximum speed. Where is the speed maximum? The speed is maximum at the mean position. At mean position. Where is the acceleration maximum? At both the extreme positions. Keep this in mind. Clear, my warriors? Everybody knows about this? Cool. Shall we go ahead? Okay, great. Next, angular frequency and time period. Let's see the quick formulas for all of these things. So, angular frequency, I had told you it is nothing but omega. Time period is t. Omega is 2 pi by time period. Also remember one more thing, 1 by time period is frequency. So you can also write this as 2 pi into f. All of them are very important formulas. Sometimes frequency is given in, sometimes the frequency will be given in hertz. Sometimes angular frequency is given, that is in radians per second. Sometimes you might be given the time period, which is obviously in seconds. So you need to how to convert into each thing. Sana, no, I mean, you can go to HC Verma, Tathwa, PYQs, Arihant, DC Pandey. These are enough. Hello, Arjun. All right. Hi, Dakshin. Okay. So, yeah, these are good books. Now, next thing, energy of SHM. Let's revise the formulas quickly. Remember, the energy keeps on oscillating between kinetic and potential energy, and their sum remains the constant. Correct? I hope you remember this. And the potential energy is always a quadratic function, of x. Keep this in mind. So, if you have a simple spring mass system or any simple harmonic motion which goes back and forth, this line represents the total energy. You can see as the block goes back and forth, the total energy never changes. But you can see the kinetic energy increases, decreases. Similarly, potential energy decreases, increases. It makes sure that the kinetic and the potential energy sum remains constant. You can see that very easily. Over here, kinetic energy is 0, potential energy is maximum. As potential energy decreases, kinetic energy increases. And again it converts back. So their sum always remains constant. If I had to give you formulas for energy and all of these things, so for kinetic energy, obviously it is half mv square. Potential energy, it is half k x square. Their sum, which is the total energy, which is k plus u, is just half k amplitude square. Keep this in mind, very, very important. Half k amplitude square. Got it, my warriors? This is something which you should definitely know. Next thing, you can also write the kinetic and the potential energies in terms of time. How? Substitute the value of velocity. For example, this will become half m. Velocity's formula is a omega cos omega t. So it can become a square omega square cos square omega t plus phi. Similarly, this equation, x is a sin omega t plus phi. So this can also become half k a square, and here you will have sine square omega t plus phi. Got it? As simple as that. Okay. So Sriram, I will probably suggest you to watch my lecture number 2 or 3, where I have taught in detail about phases and phase difference. Have a look at it. Just search for lecture 2 or lecture 3 of Simple Harmonic Motion on YouTube. Shreyas sir. Just put Shreyas sir, a Simple Harmonic Motion or Oscillations. You will get it. There is a lecture detailed on phase difference and all of that, and the exact same problem what you are talking about is there in some other way, or maybe the exact same form. Just have a look at it. Okay, bacha, you can do that. Cool. All right. Now, next thing. Let's talk about the forces and how can you find out the time period of SHM. Whenever you have to find the time period of SHM, remember there are multiple ways of finding it. One of the way is to somehow show that the force is proportional to x. If you can show that the restoring force is proportional to x, your job is done. Keep this in mind. So one way is by restoring force. The restoring force is basically proportional to x. From that, the value of the constant that you get, from that you can find the time period. Okay, from that you can find the time period. And the value of the time period is 2 pi under root of m by k. Keep this in mind. So time period is 2 pi under root m by k, where k is that constant of proportionality and m is the mass which is oscillating. Another way is, if you know the energy, then use F is minus du by dx. Once you differentiate derivative of u with respect to x, again you will get force as a proportion, force proportional to x. Again you can find the time period. So if energy is given, find force. If force is given, then find the constant of proportionality. That's it. Also remember, the third way is via equations. So via equation, x as a function of some time. So if x is a sin omega t plus phi, you can find out omega, you can find time period, you can find frequency, all of that. So these are some different ways via which you can find the time period of SHM. Keep this in mind. There are some problems where you might not be able to find it directly because the springs are in a combination. So all you need to do is combine the springs and find the equivalent constant. Whenever the springs are in series, keep this in mind, very, very important. The formula is that of parallel. So 1 by ks is 1 by k1 plus 1 by k2. So for series, use the resistors in parallel formula. Similarly, if the springs are in parallel, so if they are in parallel, then use the series resistors formula. So Kp will be K1 plus K2. Cool? Okay. One more thing. In parallel, when you extend this mass and the springs also get stretched or compressed, you know what is same in both of them? Come on, put it up in the chat box. What is same in both the springs? It's the x which is same. X is same, but forces F1 and F2 may not be the same because springs could be different. F is kx, x is same, k's are different, forces are different. But when springs are in series, then the force is same. F1, F2, both are same. The spring forces are same. Because it's like one single wire. Look at this. This is one wire, coiled, coiled, coiled. Again straight, again coil, coil, coil. It's one single wire. So the tension in that wire is the same, which is F1 equals to F2. If F is same, K is different, what else will be different? X. So you will see generally these springs will have different amounts of X's. Here X is same, here X is different. Got it? Hello Akshay Raja. Hello JS1A. Good evening Bachalo. Awesome Shriram. Okay. Next, phase difference and phasors. See, I have told you this, that whenever you have a simple harmonic motion, the shadow, the projection or of it, or sorry, rather if you have a circular motion, the shadow, the projection of that circular motion is an oscillating, basically a simple harmonic motion. Essentially what it means is, if you have a particle which is going in uniform circular motion, if you only consider the y coordinate or x coordinate of that particle, if you only consider the y coordinate or the x coordinate, which is the projection on the y-axis or on the x-axis, it performs a simple harmonic motion. Okay, the shadow exactly is SHM. That's why you see so many similarities between UCM and SHM. Recollect, in uniform circular motion, the time period is 2 pi by omega. Here also, time period is 2 pi by omega. Doesn't it resemble each other? And understand, this circular motion will have some radius. That radius will become the amplitude. So the radius of this becomes the amplitude of oscillation. Keep this in mind. Okay, the radius becomes the amplitude. Here omega represents angular speed. This is angular speed, which is nothing but omega. Here, you know how quickly you are oscillating? That is angular frequency. The word used is different, symbol used is same. Omega symbol is same. You are calling it differently in different chapters. Keep this in mind. Now, what is this phase space and real space, or phasor diagram and real diagram? See, phasor diagram is a tool to solve problems pertaining to SHM. Meaning, see, if this block is going up and down, it's not actually a shadow of some physical thing. There is nothing like an actual circular motion which is happening beside it, whose shadow is this oscillating spring block system. The spring block system is existing independently, correct? But we can understand, perceive and visualize things easily when it is in a circle. Okay? And that's why we create a hypothetical space. It's like virtual reality, or you have your 3D space. You create a space which corresponds to this real space. There are some connections between these two things. Like the amplitude and the radius is same. Angular speed and angular frequency is same. Time period is same. Then it helps us solve the problem. So a particle which is going around in a circle is basically in a unrealistic, it's an imaginary space. That imaginary space is called as the phase space. And why the word phase is used is because, simply put, look at this. If, imagine, the particle is right over here, and let's say it has displaced the displacement, angular displacement, right from here till here. Let's say it was here, and now it goes here. The angular displacement is omega t. Angular displacement, speed into time is displacement. Then if I draw the perpendicular over here, this one over here, observe, this one over here will be, obviously, since this is this angle, this will be also the same, and this hypotenuse has a length of a, this is right angle. So what will be the y coordinate? Can you guess what the y coordinate will be? It will be a sine, so it will be a sine omega t. This is basically called as your phase. It tells you what is your angular position. So in circular motion, this angle represents the actual angle wise position, but in SHM it tells me the phase. It tells me, you know, the current situation of that particle, where that particle is. So you can, if you think about, you know, phase, you might not be able to comprehend so easily. So convert it into circular motion, then you will understand easily. If I tell you the phase of the SHM is 90 degrees, that means the angular position is 90 degrees of the circular motion. Angular position of the imaginary circular motion is 90 degrees. So when that particle is at 90 degrees, where will that SHM be? Obviously the SHM will be here, because if the particle is here, the SHM will be here. That means the SHM is at extreme position. The SHM is at extreme position. Is that clear? Sai Ganesh, I don't know, bacha. We are all waiting. Yes. So IGT, it will be available in Zero to Hero series probably. Just have a look at it. Okay? Zero to Hero playlist. Alrighty. Now, this is another interesting graph or another way of showing, you know, phasor diagrams. Look at this. The particle is performing simple harmonic motion because you can think of it this way. This particle which is going around the circle, either the x coordinate or the y coordinate, you can see both of them are performing SHM. And this angle that you see which is covered, that angle which is covered is called as the phase of the SHM. Okay? Yep. So when is the phase 180? Okay, simple. Say for example, you know, you start from here, you reach here. Here it will be 180 degrees. 0, 90, 180, 270, 360, which is same as 0. So 180 means the UCM particle is here, the shadow will be here. That means this block is at the mean position. So when the block is at the mean position, this has reached 180 degrees. Is that understood? Thank you, Manish. Very good, very good. All right, let's move ahead. Now, what is the meaning of phase difference? See, two particles might be performing SHM. Each SHM has an imaginary space where you have some particles performing circular motion. Each SHM has an imaginary space which is called as the phase diagram, phase space, where it is performing circular motion, whose shadow is the SHM. Imagine two SHMs, there will be two circular motions. Both the circular motions will be moving, but it's not necessary they are moving simultaneously. There could be some delay in their movement. Look at this. Look at these two SHMs, look at these two SHMs. These are in sync. These are out of sync. These two SHMs are said to be in phase, whereas these two SHMs are said to be out of phase. What it means is that if you draw their phasor diagrams, okay, let's say this is the circular motion, okay, you draw two axes for simplicity, and if you draw the phasor of one particle and you draw the phasor of the other particle, this is particle 2, you will see there might be some angle between them, and these two particles go around the circle like this. They go around the circle like this. If they go around the circle making some angle, you can see their shadows will not be simultaneous. Their shadows will also have some lag between them, unless both of them are coincident on each other. Then their shadows will also go up and down together, just like these two. So the angle between them is called delta phi, which is nothing but the phase difference. This is called as the phase difference. If they are in phase, then the phase difference is 0, and if they are out of phase, then it is said to be phase difference is pi radian. Anything else, it's just not in phase. It's just not in phase. I hope this is clear. All right. Another thing, if you superimpose two SHMs, okay, if you superimpose two SHMs. Now when I say superimpose, it means you add two SHMs, you contribute each SHM's value and see the resultant SHM. Meaning, let's say there is one particle going like this. Another particle with respect to that is going like this. So when both their effects are combined, meaning the other particle is performing SHM and this particle is also performing SHM, you will see a bigger SHM. You will see the resultant SHM. You will see resultant SHM. Got it? So that is called as superimposing SHMs to produce a resultant motion. Now there are two ways of combining SHMs. One is in 1D and the second way is in 2 dimension. You would remember, if you combine two SHMs in 1D, then the resultant is also a SHM and the SHM's amplitude is nothing but the vector sum of amplitudes of the SHMs which are being added. Recollect that. If there are two SHMs which are added, you take the amplitude of one SHM, amplitude of two SHM, and what will be the angle between them? The angle between them is exactly the phase difference. And that's it. You add them vectorially, you will get the amplitude of the resultant SHM. Is that something which you recollect? Yes, KS Prasant, you will get it. Yep. And in 2D, there are multiple outputs which are possible. One is it could be a straight line. Another is it could be a circle. It could be also an ellipse. Now ellipse could be regular. It could be regular or rotated ellipse. All these possibilities are there. In 2D, when I say 2D SHMs superimpose, one SHM is going like this, other SHM with respect to that is going like that. Other SHM is going with respect to that. So multiple possibilities are there, and that possibility depends on the phase difference between the two. If you recollect, straight line is when they are basically in phase or out of phase, or they are out of phase. These two things happen when delta phi is basically, not any one of these things. So delta phi is not 0 and it is not pi radians. Circle is the possibility when the amplitudes are equal. So when amplitude in x equals the amplitude in y, then it becomes a circle. If the amplitude in x and y are not equal, then the resultant is an ellipse. That's what it is. Okay, is that clear? So these are the important things which you should keep in mind. Just like you have linear SHM, you also have angular SHM. And in angular SHM, what happens? You see some object going back and forth but angle wise, like twisting your body. You twist like this and you do a dance, you are doing exercise. This is angular SHM. This is my equilibrium position, this is my extreme position. This is equilibrium, this is extreme. I am doing a periodic oscillatory motion but angle wise, so angular SHM. Also a simple pendulum is also angular SHM. Extreme, mean, extreme, mean, extreme, angular SHM. Here, instead of force proportional to x, you will have the torque proportional to theta. This is your torque. Remember that. This is your angular displacement. And here you have something called as the constant of torsion, or you can just put it as C. This is minus because it's opposite. This stands for restoring. And this is your constant, okay, of proportionality. Here also time period is 2 pi under root. Instead of mass, you have moment of inertia, and instead of K, you have C. That's the only change. So this I stands for moment of inertia. Keep this in mind. So what are these theta max over here? These are your extreme situations. This is your mean. In fact, this represents your amplitude. This represents your amplitude. How much extent does it go degree wise or radian wise on left or right side? Okay. Dakshin, Lissajous figures are those figures which you get when you superimpose two or more SHMs in 2D, and using Lissajous figures you can compare and find out unknown frequencies. So that is a part of like electronics subject. So if you have taken up electronics, or when you take up electronics and computer science engineering, or electronics and electrical engineering, so then you study all those things where you can compare frequencies and all of that. So it's just superposition of two oscillations in 2D. That's what it is. Okay, Dakshin? Great. Now Based on this, you also have the torsional pendulum, which I just gave it to you over here, 2 pi under root I by C. So if you know, there is a rod which can be twisted and it has a torsion. Torsion means bending it, twisting it. The torsional constant is C, moment of inertia is I, the time period of oscillation, the time period with which it oscillates is given by 2 pi under root moment of inertia by C. Keep this in mind. Similarly, for simple pendulum, yes, Rohit, yep. Yeah, what else? I mean, I hope that is fine with you. At least I'm wearing something, right? Okay, so simple pendulum is where you have a point mass and the thread is basically massless. That's very important. The thread should be massless. If the thread has mass, then it becomes a physical pendulum. That's very important. Okay, so what's the time period of a simple pendulum? It is 2 pi under root L by G. Keep this in mind. You should also know for a seconds pendulum, the time period is 2 seconds. Many people make a mistake and they say seconds pendulum has a time period of only 1 second. That is wrong. Please keep this in mind. Okay, next thing. For a simple pendulum which is in an accelerated frame, meaning the lift is going either up or down, in those cases remember G will change, hence time period also will change. If the lift is going up, the effective value of gravity will become G plus A, because you are going up, everything, the pseudo force will add with the weight. Pseudo force and weight are together, so G plus A. If the lift goes down, then the G effective will be G minus A. Hence, the time period will also change. It will become 2 pi under root L by G plus A, and here the time period will be 2 pi under root L by G minus A. So time period also depends on the accelerated frame of reference. Keep this in mind. And one last thing, study only nobody knows bacha, but hopefully April and May. Okay. Yes, I mean, Rinis, I have already made a timetable for JEE 2022 students. If you are 2022 student, I have given a 45-day beautiful timetable plan. So please follow that, bacha. Okay. So going ahead, the physical pendulum. The physical pendulum means, where the point or the mass is not concentrated at a point, but it would be distributed. Like maybe this remote. It's not a simple pendulum. The mass is scattered everywhere. So when it oscillates, that is a physical pendulum. So in such cases, when the mass is not at a point, all you need to do is measure the distance from the hinge, that is the support, till the center of mass. Let's say that distance is L. And when you leave it, it's going to oscillate. So you will see in such cases, the time period of oscillation is 2 pi under root of I by mgl. What is I? Again, moment of inertia. What is L? Distance from where? The hinge. It's from the hinge to the center of mass. This is the time period formula. Keep this in mind. So Kavi, when the lift goes up, what happens is gravity is acting down. Also understand, even the pseudo force will act opposite to the acceleration, because pseudo force always acts opposite, right? So pseudo force and gravity will help each other. So effectively, what is happening? The net force is increasing down. So you will have more weight. More weight means G plus A or mg plus ma. Mg plus ma means G plus A will come out common, or you can take it outside. Hence, effective gravity is G plus A. Yes, Sri Harshit, the 2-hour video in the crash courses, be it work power energy or any other chapter, these are one shot, to the point videos, no nonsense, to the point. That means all the important concepts which are important from JEE Main's perspective are covered. Number one, you are being taught the concept application, and once you are taught, you are being given an assignment, chapter assignment with many problems from Tattva module, our flagship, module, the Tattva module. When you solve that, you will get a complete understanding of the chapter. And then once you give the part test, you will have a good understanding of few chapters together. And when you give those full syllabus mock tests, That's it. That's when you start preparing yourself for the final JEE exam. Okay? Yes, that's how it is. All right. So make sure that when you are registering for the crash course, you number one, keep this in mind that it is in English medium, and if you get an option of dates, you can choose whichever date you want. All right, you will not miss any class. Number one. Number three that I would like to tell you is that all these crash courses classes are also recorded. So even if you miss any class, it's okay, bacha log. So you can watch the recorded class again and again, or even if you want to revise, it's okay. You can watch it. Also remember, the PDF of the classes are given to you. Okay, the PDF, the handwritten notes are given to you. So that is very useful. Sometimes there are additional problems which are also there in the PDFs, which you can solve it like homework. It depends from teacher to teacher. You will get a lot of homework, so depending on the classes. So make sure you make the full use of it. So are you guys now ready for solving some questions on this? 2023, Surya, 2022 students only don't know how many attempts are there. 99% it is 2 attempts, but it is not yet official. So 2023 is very far away. Things can change dynamically. So let's not worry about that. Even if you have 1 or 2 or 3, how does it matter? It's at the end of the day, you have to prepare for at least 1, right? Only 1 exam marks counts. So don't worry about it. Okay. Yes, study time you can. Okay. So lots of PYQs coming in front of you. So get ready, my warriors. Here is the first question coming up on your screen. This was asked in JEE 2019, and I will give you a timer of 1 minute, and let's see how many of you can get this. So Manish, you will get the PDF only on the Telegram channel. You need to check it out over there if you are a part of the new Telegram channel. And obviously you will not get it now, you will get it after a day maximum. Okay. Chalo, let's see if you can solve this question. Okay. Mohammad Anas, if you do only sure shot topics, I don't know which sure shot you're talking about. Who's sure shot? I don't know. I have not given any sure shot topics, at least till now. I have given you all the topics, all the important topics which I had given in the 45-day plan. If you do that, yes, then you will crack. If you watch my 45-day plan, for sure. Okay, cool. All right, let's see how many of you can get this answer. And all right, the time is up, and let's see what the correct answer should be. Here it is. Particle executes SHM with amplitude of 5. So let's see whatever we know. The amplitude is basically 5 and centimeters, and the particle is at 4 centimeter. Then the velocity is equal to the acceleration. Interesting. So when x is equal to 4 centimeters, then the velocity is equal to the acceleration. The question is, what is the time period? This is the question. Let's try to see what in all formulas we know. If velocity is equal to acceleration, more probably I need to write velocity in terms of x, acceleration in terms of x, and that will probably solve the problem. Okay, let's try this out then. So velocity in terms of x, do I know a formula? Yes. What is it? Omega under root of a square minus x square. Correct? That's the formula for velocity. And what's the formula for acceleration? It's nothing but omega square x, of course. Omega cancels, and one of the omega remains. So omega will be root of a square minus x square divided by x. Correct? Okay, many of you are saying A, some of you are also saying C. Let's find this out. Next, substitute everything. Amplitude is 5, x is 4, so 5 square minus 4 square divided by 4. So 5 square 25 minus 16, that's 9. 9's root is 3, so this will be 3 by 4. But wait a minute, omega. What's omega? Omega is nothing but 2 pi by t, right? So this is also 2 pi by t. That means the time period will be, check this out, 2 4s are 8, 8 pi, and 3 comes down, so 8 pi by 3. And I have an option like that. It's not A. All those of you who said A are wrong. Obviously option C is correct. Proud of you, those of you who said C, and don't worry if you got it as the wrong answer or did not get it. Now you know how to solve this question. Shall we move ahead? Yes, Nikhil, very good. Divyanshi, very good. Nithil, excellent. Haranth, very good, very good. Roshni, very good, very good. Surya, no, it's not. No, Manish, it's not. Okay. SL Aurora is good, but it's a recommended book for Olympiads rather than JEE. So you can solve SL Aurora, yes, but I would suggest you to do HC Verma, Irodov, DC Pandey, Arihant, PYQ's Tattva module, more than enough to crack JEE. Okay, so moving ahead to the next question. The ratio of maximum acceleration to maximum velocity in a SHM when is 10 per seconds, and when t is 0, displacement is 5. What is the maximum acceleration? Initial phase is pi by 4. Okay, Datta Prasad Pore, can you just rewatch the class? Can you rewatch that particular solution? Just rewind back a little bit, watch it slowly by even taking a pause. You can even come back to this question, you know, even in the live class. I hope that will help you. I explained everything in detail, don't worry. Okay, observe this. Maximum acceleration to maximum velocity is given. So I'll just give you the given parts and I'll give you some time. So ratio of maximum velocity upon maximum acceleration is given to be 10. Next, at time 0, displacement is 5. So at t is equal to 0, initial position x0 is 5 meters and initial phase phi value is also given to be pi by 4. The question is, what is the maximum acceleration? This is the question. See if you can solve this. Okay, some of you are saying A. Let's figure this out. I don't know whether it is A, B, C, D. You need to tell me. I'm going to solve and I'm going to get the answer. Okay, let's see. I know the ratio of velocity and acceleration and I need to find maximum acceleration. Maximum acceleration is going to occur at the extreme position. Extreme means when x is amplitude. So if I want to find max acceleration, I need to know the amplitude and I need to know omega, because acceleration is omega square x. So how do we do that? Think about it. Okay, many of you are saying option A, Anavandana PP, very good bacha. I'm so glad you finished it. So here is what I will do. Think x is in general a sine omega t plus phi, right? How about substituting certain values? X is x0, basically time is 0. So when the value of time is 0, phi is basically pi by 4. Amplitude I do not know. X is nothing but 5. X is nothing but 5. So 5 is equal to a sine of 45 degrees is 1 by root 2. So 1 by root 2. Hence amplitude is 5 root 2. Cool? Very good. Last thing, you want to find maximum acceleration? Yep. Sir, max acceleration to max velocity is 10. Oh, is it? The ratio of max acceleration to max velocity. My bad. Thank you. Thank you so much for pointing it out. This was acceleration to velocity. All right. Maximum acceleration to maximum velocity was given to be 10. Great. Now, observe, if I know amplitude, what else do I need? Think, I just need omega value and my job is done. Look at this. This ratio, I can write it down very easily, trust me. A max is nothing but omega square into x, which happens to be a, and V max happens to be omega into a. Acceleration is omega square x, velocity is omega a for maximum value, and this is nothing but 10. Naturally, omega a gets cancelled, so omega will be just 10. Once I get this, my job is done. You have to just find a max. A max is omega square into a, so omega square, that means 10 square, amplitude, that is 5 root 2, so that's it. It will become 500 root 2. Is it there? Option A, correct. Correct. Yes, I hope this is clear. Tanishka Jadhav, my name is Shreyas, and yeah, you can find it also in the description box and my session title, of course, I hope. Okay, so that's the answer. All right, moving on to the next question. Very good, Rahul Ratan, very good, excellent. Oh yes, Haranth, I'll be doing it, don't worry. I'm not sure if this diagram is so clear, but let me just write it properly. This is E1, this is E2, and I don't know whether you can see this. This is A and this is 2A. Okay. Now this is momentum. This is momentum, and this is position. This is what the graph is. So I think the print is not so clear, but I'm writing it for you. Cool. Now the question is, there is a phase space diagram, momentum versus position diagram is given, and it is looking like a circle at the origin. At the center is at the origin. The two circles represent the same oscillator, very important, but different initial conditions. Something is different, so the initial conditions are different. E1 and E2 are the total energies respectively. So what is the question? The question is, what is the relationship between the energies? I'm very good, Arsham. I hope you two are doing good. Okay, so guys, if you're not yet subscribe to the channel or not yet like the video, make sure you do that right now. Support the channel, because we need your help to grow. Only when we grow, you grow, and when you grow, we grow. Remember, it's a mutual thing, vicious circle. So the logic used over here is, energy in general is half Ka square, because same oscillator, that means K is same. Got it? K is same. Hence, E1 by E2 will be half goes, Kk goes, it will be A1 by A2 whole square. Now observe the diagram carefully. E1 has an amplitude of 2A. Reason, check the maximum displacement, it's 2A. For the second time, when it is E2, the energy is E2, the maximum displacement is A. Hence, A1 is nothing but 2A, A2 is nothing but just A and whole square, which means it is 4. 2 square is 4. Hence, E1 will be 4 times of E2. Is such an option there? Is such an option there? Yes, it is. Option C. Got it? Sriji, it's okay. Even if you joined in late, even in a live class, bacha log. Hi Niza, okay, but you can even go back and come to the current position. Also, let me tell you, you can watch the lecture from now on, and whatever you miss, you watch it later on. The fun of live class is completely different. Hi Chikalaka, Daripia. So Majid, nice to see you with your new display picture. It makes my day when I see students changing their display pictures to our Ninja Warriors logo. It shows that you immensely love our channel and you are really enthusiastic about all the lectures that we conduct over here. Thank you so much for changing it. Next question. This was asked in 2019. A particle undergoing SHM has time-dependent displacement given by this. Interesting. The kinetic energy to potential energy of this particle at time 210 seconds is how much? Let's figure this out. Okay. Now, x as a function of time is given at 210 seconds. Let's substitute. So, x at 210 seconds will be a sine pi by 90 into 210. Why am I doing that? Because only if I find out x will I be able to find out potential, kinetic, all those energies. Because we have to find the ratio of them. Let's do that. Alright. Thank you, FF Gaming. Okay. So next thing, this will be a 0, 0 goes 937. So this will become 7 pi by 3. 7 pi by 3, can I write it as 2 pi plus pi by 3? Correct? 7 pi by 3 is 2 pi plus pi by 3. Correct? Great. Now whenever I have 2 pi plus something, it will just become sine of that something. So this will become just sine. This is trigonometry, as simple as that. Sine of pi by 3. And sine of pi by 3, which is sine of 60, is nothing but root 3 divided by 2. So that is your x value. Now why did I find out x? You will understand in the next step. Observe. Ratio of kinetic to potential is asked. So kinetic upon potential is asked. What is kinetic energy formula? It's half mv square. What's potential energy formula? Half K x square. Half goes. But I also have K and M. I don't know what to do with it. Hold on, let's do something. First, let's see what we can do next. V in terms of x, yes, I know what it is. V is omega root a square minus x square. So V square is omega square a square minus x square. That's the formula I can use. Divided by x square. Everybody agrees with this? Everybody agrees with this? Got it till this point? Okay. Now what's the next thing? Is omega somehow related to m and k? Yes, it is. Remember, I had given you this formula. Time period is 2 pi under root m by k, and time period is also 2 pi by omega. So from this, what do you get? Omega is basically root of k by m. This is a very important formula. So use that over here. Instead of omega, write k by m root. So square will be obviously just k by m. That's it, right? And rest of the things as it is. So this is m by k, and this is a square minus x square, of course, and this is x square. Oh, these two gets cancelled. That's the best part. So mm goes, k goes. And now start substituting x in terms of a, which I have figured it out over here. So this will be a square minus x square will be a square. Root 3 square is 3. 2 square is 4, correct? This is 4. Divided by x square. X is a root 3 by 2. So square will be a square into 3 again by 4. A square cancels out. So what is remaining? 1 minus 3 by 4 upon 3 by 4. 1 minus 3/4 is 1/4. So this will be 1/4 by 3/4. 4 goes, 1 by 3 is remaining. Is such an option there somewhere? Yep, it is. Yep, Roshni, it is. Okay. So what have we done? In this given question, what was given? You have to find the ratio of kinetic and potential energy at certain time. So first thing we figured out is what is the value of x position by substituting that time. So when I substituted time over here. Look at this. This is the time value. I substituted it as 210 seconds. I got this. And by trigonometry, I got this is sine pi by 3, which is sine 60, which is root 3 by 2 times of a. Okay. Then here, this is half mv square. This is half kx square. That's standard formula. Half goes. M by k remains. Omega square is there. How did I get this? This is your standard formula. Velocity is root of a square minus x square, the whole thing into omega. That formula I've used. Omega is root k by m. So square is k by m. Cancels out. That's it. Now, the last thing, substitute the value of x which I got here. Put it over here. Substitute. Just everything gets cancelled out. Nothing is remaining. Is that okay, Sudarshan SS? Bacha log? Cool. Shall we go ahead? So that's a very good question which was asked in 2019. Yep. Are you guys loving these questions? Are these opening up new avenues? Are these like activating new neurons in your head? Yeah. Okay. It is there, Bindu. It is there. Go to additional content. Go to additional content, you will see it. Okay. In content, go to additional content. In that, you will be able to see the tattva. Okay. Cool. Next. In an engine, the piston undergoes vertical simple harmonic motion with 7 centimeters amplitude. There is something which is on the top of the piston as it moves up and down. The motor speed is slowly increased. At what frequency do you think the washer no longer stays in contact with the piston? This is a very good question. Let's try to solve this. And this is very common also. Imagine this is your piston. Okay, this is your piston. Okay, and this piston is going up and down. It's performing oscillation. On that piston, you have placed some washer. Okay, this is your washer. So this one over here, this is your washer. Now, there will be certain forces acting on that washer. What kind of forces are there? Think one mg will be there and one normal will be there. But as per the given question, the washer loses contact. It no longer stays in contact. That means the normal force will become 0. This can only happen in one situation, when mg and pseudo force balance each other. Now you'll be like, sir, why will pseudo force be there? Okay, if you don't want pseudo force, then provide acceleration, sit in the inertial frame. The point is, if you're in the piston frame of reference, it is non-inertial because it is accelerating up and down. Do not forget, the piston is performing simple harmonic motion. So it is obviously accelerating up and down. Got it? Got it? Clear till this point? So if mg and pseudo force, why the pseudo force came? Because of the acceleration of that piston. You are sitting on the piston. If you are a non-inertial frame, you are moving up and down. Okay, with the piston, it's a non-inertial frame. If the pseudo force cancels mg, normal will be 0. If pseudo force is there, that means there must be some kind of mass into acceleration of that particular piston. Now, for it to lose contact, pseudo force is weight, therefore mass into acceleration of that piston is equal to mg. mm goes, so acceleration of the piston is g. And when do you think it will lose contact? It will lose contact when the acceleration is maximum. That's the first time it will lose contact. Think about it. It's going up and down. When the acceleration is maximum, that's when the pseudo force is maximum. That's when the contact will be lost. It will fly off. And that is maximum at your extreme positions. So for it to lose contact, therefore you will see the acceleration of the piston is maximum, which is going to happen at the extreme position. Everybody fine till here? Let me know. Acceleration is maximum at the extreme position. Cool. Now, once you understand the acceleration is maximum at the extreme position, that's when the pseudo force is maximum. That's when that upward force is just enough to balance the weight. So just substitute the values. What's the formula for acceleration? It is nothing but omega square x, but x in this case will be the amplitude. Why? Because extreme means x is equal to a. Now lex is, this is equal to g. Now just substitute all the values. Okay, amplitude is 7, g is obviously 10, and the question is frequency is asked. So omega is 2 pi f, so 2 pi f whole square into amplitude, that's 7 centimeters, so that's 7 by 100 meters is equal to g. Now you can see some special things happening over here. Pi square and g will cancel. Pi is 3.14, square of it is roughly 9.8 and around, so you can cancel them. That's a very valid approximation. So it will become 4 pi square into f square into 7 by 100 is equal to g. I'm just going to cancel g and pi square. Therefore, f square will be equal to 100 by 4. I can just write this 100 by 4 as 25. Hold on. I'll just take that 100 there and 4 here. So that is just 25. And I will have the 7 downstairs. Therefore, f will be 5 by root of 7. Now, root of 7 will be less than 3 but more than 2, because root 9 is 3, root 4 is 2. So it will be somewhere between 3 and 2. Probably very close to the half of it, approximately 2.5. 5 by 2.5, 5 by 2.5, 2.5 is half of 5. Obviously the value will be very close to 2, very close to 2. Is there a value close to 2? Yes, there is, 1.9. That's how I will find it out. Okay, approximately. I hope that is making sense. You don't have to sit and find the value of root 7, of course, and sit and divide those values. Yes, that's unnecessary because the options are given. Okay, perfecto. Let's move on to the next one. All right, let's see the next question coming up on your screen. Get ready. Come on, guys. Show some josh. Show some excitement. Are you guys nervous? Are you guys very happy? Are you guys feeling lost? Are you guys like, yeah, what is it? Let me know. I want to know what it is. Thank you, Bala Murugan, so much. All right, Shall we do this next question? Linear harmonic oscillator has a constant of this much, amplitude of this much, energy is this much. What is the maximum, minimum potential kinetic energies? Now this is going to blow your mind. This was asked in 1989. Look at the year 1989. It's a crazy question. The crux of this question is that you will understand it's not necessary that the potential energy is zero at mean position. You have been taught, oh by the way, multiple options are correct. You have been taught that, you know, at mean potential is zero. But let me remind you, if this is potential energy versus X graph, if the graph is like this, still it is SHM. If the graph is like this, still it is SHM. Even if the graph is like this, still it is SHM. As long as it is a quadratic function, okay, it's a quadratic function, it is always going to be SHM. Because the moment you have a quadratic function x square plus bx plus c and you differentiate it du by dx, you are going to get a linear function, and when you have a linear function, this du by dx, do not forget, is the force. So if the force is a linear function, it just says that it has to be a simple harmonic motion. So any quadratic function will do. Keep this in mind. Alright, now this is MCQ, multiple correct options. Beware, more than one options could be correct. So here is my logic. Let's just to find out what is the spring potential energy. So the spring potential energy will be half K A square. This is at extreme position. Extreme, when extension is maximum. So half K is 2 into 10 to the power 6 into amplitude, which is 0.01, that is 10 to the power minus 2 whole square. 2 goes. This is 10 to the power minus 4. This is 10 to the power 6. So it will become 100 joules. This is the spring potential energy. Now one more thing. Keep this in mind. At extreme position, what is the speciality? It stops. That means kinetic energy is zero. That means the total energy should be potential energy. The total energy should be the potential energy. Got it? But here is the catch. The total energy given is 160 joules. 160 is not the spring potential energy. That's the crazy thing. Like 160 joules is not the spring potential energy. So that means you have to think that potential energy might have some constant term. That's what. So think as if 160 is some constant term plus the spring potential energy. That spring potential energy. That means your zero reference is there. Remember, potential energy can be assumed zero anywhere. So adding something to potential energy or subtracting something does not make any difference to it. Tushar, whenever you get demotivated by solving physics MCQs, remember one thing, most likely you have not done questions in multiple ways, multiple angles. Number two, try to solve problems by different ways, going reverse, going forward, and also manipulating, also thinking what will happen if this is done, what will happen if this is not there, those kind of things, and also spending a lot of time on simple questions and average questions before going to difficult questions. Try this, it will help. Thank you, Prince. Okay, now if this is understood, you can immediately find what that constant will be. That constant is going to be 60 joules. This constant is the least energy that will be always there. That's like a constant plus spring potential energy. Hence, you can think at mean position, the potential energy will be how much? The potential energy will be 60 joules at mean. Are you getting it? That constant is always added to spring to get you the total potential energy. So at mean position, what will happen? The spring will be natural, it will be at natural length. So no energy in that. So what is the potential energy? The potential energy is just that constant, that number which has been just added, 60 joules. That is the catch. So the minimum potential energy, is it given? No. Okay, everything is maximum. So now the problem becomes simple. The problem becomes simple. See, look at this. Observe carefully. The least potential energy is 60. The maximum potential energy, where is it? The maximum potential energy will be 160. Least is 60. Maximum will be 160, obviously. That's when it is at the extreme position. Hence, can I say the difference between these two, which is 160 minus 60, that will be, which is 100 joules, that will be the kinetic energy, max possible kinetic energy. Is that understood? So at the mean, potential is 60, at extreme it is 160, difference 160 minus 60 is 100, so 100 joules is that kinetic energy compensation. Hence, you should get the maximum kinetic energy is 100 joules. Everybody gets this? Okay. Maximum potential energy is 160 joules. So I hope B and C are correct. Yes, it is. Maximum potential is not 100. Maximum potential energy is 160 joules. Hello, P. Ankita. Thank you, everyone. All right. Why is the title changed into waves? Is it Dakshin? I'm not sure why is it changed into waves. It should not be the case, bacha. Okay, I'm not sure. It should be oscillations. Okay. I'll just see if it has been changed. No, it is SHM only. Okay, it is SHM. It's fine. Okay. Isn't 100 joules max, Arvinder? No, I'll tell you what, bacha. See, look at this. I'll explain this to you graphically. So many students face this difficulty out here. Just hold on. Okay, I'll explain this to you graphically. You will get it. Okay, observe this. Observe this carefully. Okay, so this is your 160 joules. Okay, this is your 160 joules. Your potential energy is maximum at these two extremes. This is extreme points. This is also extreme points. This happens to be your mean position. Got it? And I can also draw a zero energy line. This is 0 joules line. And the kinetic energy graph will look something like this. This is your kinetic energy, okay, and the yellow one is your potential energy graph. Now what has happened is, because this constant is there, this constant is telling that you at least have 60 joules, which is always there. So this is 60 joules, this is 160 joules. So that difference, can you see this difference is basically 100 joules. And this 100 joules will be there with kinetic energy, that maximum kinetic energy. Is that clear? Everybody understood? Okay. Oh, this waves. Oh, this is not supposed to be waves. This is supposed to be SHM. Ignore that. Okay, okay, cool. Got it? So that's how it is. All right. Moving on to the next question. That's why it's a brilliant question, and that's why, you know, many students ask me, sir, should I just do only the last 4 or 5 years PYQs, because there are multiple attempts and multiple questions and all of that. Yes, there are a lot of questions, but trust me, there are very good concepts in the last, 40, 50 years of JEE. There are so nice questions, so nice concepts, you cannot choose to ignore. And that time, one paper used to happen in 1 year, and they used to ask brilliant questions, conceptual, tricky questions. So that's why you should solve very old papers also. Next question. Divya, you need to know basically some amount of derivations at least. You need to solve good level of questions. You need to practice variety of questions, and you need to visualize. You need to be fast at calculations. Also, Divya, you need to make sure that you have solved questions by multiple angles and multiple ways. And towards the end, when you reach close to the examination, then you need to solve many mock tests. So your knowledge should be good, foundation, then variety should be good. In the end, the practice in the mock test should be good. That's how you get to 160 plus marks. Okay, let's solve this. A SHM is represented by this. What is the amplitude and the time period of the motion? Now, if you did not realize this is actually superposition of two SHMs. Do you see the plus and two terms of sine and cos? It's superposition of two SHMs in 1D. So this is basically superimpose two SHMs. And when you superimpose two SHMs, let's see what happens. So y will be 5 sine 3 pi t, and oh my bad, this is not supposed to be 3, guys. This is supposed to be root 3. This is a printing mistake, ignore that. So this will be 5 sine 3 pi t and into 5 root 3 cos 3 pi t. Now how do I add these two SHMs? If I have to add two SHMs, I need to know the amplitudes. Well, that's something which I already know. You can see that this is the amplitude and even this is the amplitude. I also need to know the phase difference between them. Guys, that's simple. One is a sine term, other is a cos term. Can you quickly let me know what is the phase difference between sine and a cos term? Okay, think about it. All right. So difference between sine and cos, what's the phase difference, guys? The phase difference is 90 degrees. You all know that, right? Sine graph starts like this. Cos graph, same time it starts like this. So there is always a phase difference of 90 degrees. Correct. That's it. Now my job is done. So you draw a vector of 5 and another vector of 5 root 3, which is at 90 degrees, and that's it. Their resultant is the amplitude which you are expecting. So this amplitude will be root of 5 root 3 square plus 5 square. 5 is common, so it will come out as 5. Root 3 square is 3 plus 1 square is 1. 3 plus 1, 4. Root of that is 2. So 5 into 2, which is nothing but 10. So the amplitude which you are expecting, that should be 10. So obviously C option and D option is ruled out. For time, remember, when you find the resultant SHM, the time period is the same or frequency is the same as each of the SHMs. So omega of the resultant is just going to be 3 pi, and omega is nothing but 2 pi by t, right? 2 pi by t is 3 pi, pi by, so time period will be 2 by 3 seconds. So I think that should be option A. 3 by 2 is wrong. If you make a silly mistake, you will get option B. Correct. No, that's how you get it. All right. Hello, Vignesh, Vicky. Join in. Yep. Okay. So all those of you are joining in late, make sure that you watch the lecture from wherever you are watching it right now, or you can even rewind back the session later on, or even in the live class and catch up at 2x speed or even at normal speed. It's okay. Perfectly fine. Okay. So isn't the resultant 2AB cos theta term? No. Remember this? The resultant amplitude is root of A1 square plus A2 square plus 2A1 A2 cos del phi. This is vector addition formula. And it so happens in this case, cos del phi will be 0 because del phi is 90. So it's just A1 square plus A2 square, which is your Pythagoras theorem. Hello, Mr. Thank you for all the hearts. Okay, Arvinder Kumar, is it understood? Let's go to the next one. We have a piston cylinder kind of arrangement. There is some pressure, there is some gas inside. The length of that cylinder is currently h, area is A, mass is m. If the piston is disturbed slightly, what's the time period of oscillation? So these kind of questions are also very common. Let's try to solve this. In these kind of questions, where there is a gas trapped inside and it's a thermodynamic kind of question combined with SHM, you need to disturb the system slightly, find out what is the force which pushes it back and propels it back so that it comes back to the mean position. which acts like the restoring force. So here is what I'll do. Right now the pressure is P. The cylinder has a length of L or H. If I move the piston slightly here, okay, if I move the piston slightly over here, if this is my displacement X, what will happen? I'm compressing. If I compress, the pressure increases. So now the new pressure P1 will be more than P, because of which the force on the walls will be more. So there will be a large force acting on this. So there will be a force F1 acting on this. Now let's try to figure out what's that force. Okay. Hi Piyush, hi Kalpana, hello everyone. Here is my logic. When I compress it, it's an insulated cylinder, so there is no way heat can go in or out. So the temperature will remain constant. So my logic is, since the temperature remains constant, pressure into volume will be also constant, and initial pressure is P, initial volume is length into area. Area into length is the volume of the cylinder. That will be constant. So the new pressure is P1. So P1 into area into the new length. Do not forget, this is the new length. How much will it be? It will be H minus X. Okay, sorry, this was not L, this was H. Let me write it as H, of course. So this will be A into H minus X. Is that clear, my warriors? Why is it H minus X? Okay, cool. Now A goes, so P1 will be nothing but PH upon H minus X. Fair enough. But I don't want P1, I want force 1. Force is pressure into area. So this will be nothing but PHA divided by H minus X. So that's your force, F1. But do not forget one thing, that this force is the net force, but not the restoring force. Reason? Observe. When the gas was trapped, there was already some pressure P, there was already some pressure force acting on the piston. When you compress it further, that excess pressure is causing the excess force. Already there was some force which was acting on the piston when the pressure was P. When you push it, there is some more force. That extra force is acting like the restoring force. Is that clear, first of all? If that is clear, then we'll move ahead. So I will write this as the restoring force. The restoring force will be technically F1 minus F. F1 minus the old force. And F1 is this one. So PHA divided by H minus X, of course. And F is just PA. Okay, that's what it is. Pressure, old pressure into area is that force. Cool. Now what do we do? Remember, whenever you want to show SHM, X should be on the top, numerator. Here, X is in the denominator. I don't like it, so bring it on the top. How? Like this. P, H, A, and H minus X, I bring it on the top like this. H minus X whole raised to minus 1, and this is minus PA. Like, what's the advantage of this? Observe. Take H common outside the bracket. So when you take H outside, it will become H raised to minus 1, and inside you will have 1 minus X by H. Here you will have minus PA. H raised to minus 1 and H will cancel out, so you'll just have PA. Now, oh, by the way, this is minus 1. Does this term look something familiar to something which I have learned in basic maths? Have you learned something in basic maths? 1 plus X raised to N. 1 plus X raised to N, when this X is small, is roughly 1 plus NX. That's your binomial approximation. Correct, Dakshin? That's it. Use that and you'll get the answer, hopefully. So this will become 1 plus N. N is minus 1. X is this whole number, which is minus X by H. That's the whole quantity, which is very small. Why is it small? Because it is disturbed slightly, very important, disturbed slightly. That's why that term over here is small. And that's it, minus PA. So this will become PA into 1, minus minus is plus. Okay, and 1 plus X by H, and here minus PA. PA and TA gets cancelled, and I'm left with PA X and divided by H. So that's your restoring force. If force is proportional to X, then the constant of proportionality is your equivalent spring constant. Constant of proportionality is your equivalent spring constant. Hence, what is the question? The time period. Time period, which is 2 pi under root mass by K, will be 2 pi under root m by K. K is PA and H goes on the top. That's the answer. So do I have it somewhere? Yes, mH by PA. There you go. Excellent. Option A. Okay. The catch, there are multiple, areas which can, lead to some confusion or probably an obstacle. Number one, people fail to understand what is the restoring force. The restoring force is not the pressure's force. It is the excess pressure's force. That means F1 minus F. So many people just write it as F1. That's one catch. Okay. Number two, understanding that the temperature is constant, hence pressure into volume will be constant. That's another catch. Number three, here, this step is also critical, where you bring this on the top to convert it into binomial form so that it is proportional to X. That's the mathematical catch. Okay, because always when forces are proportional to X, it is SHM. So bringing it on the top requires that thinking, yes, I have to bring it via binomial. That's it. After that, it is simple. Okay, Arvinder? Cool. Let's move ahead to the next one. Okay, here we have another question based on damped oscillators. It was asked in 2019. Frequency is 5 oscillations per second. The amplitude drops to half its value every 10 oscillations. After how much time will it drop to 1,000th of its original amplitude? Okay, say whenever you have a damped oscillator means the oscillation goes like this. You can see the amplitude goes down. This amplitude, if you remember, is the initial amplitude into e raised to some constant into time. This is how the amplitude decays. Basically, it decays exponentially, just like your radioactive law. Radioactive decay, the amplitude keeps on going smaller and smaller exponentially. You need to go infinite time to make it zero. This is your damped oscillation law. Keep this in mind. This is required to solve the question. Now let's start writing whatever is given. The frequency is 5 oscillations per second. Amplitude drops its value to half after 10 oscillations. Now 10 oscillations meaning how many seconds? Obviously the time is 5 oscillations is 1 second, 10 oscillations is 2 seconds. So time is 2 seconds. So let's use this law and see what do we get. The amplitude becomes half its original in a time of 2 seconds. A0 goes, so 1 by 2 will become, this is e raised to negative power, I can write it as e raised to 2c, correct? I bring it below, flip it, so it will become e raised to 2c will become 2, or you can cross multiply. Now this can be written down in logarithmic form. So log of 2 is basically 2c, or c will be log of 2 divided by 2. Okay, this is your initial condition. Next, let's use the second condition. What is the second condition given? How much time will it take to make that amplitude 1,000 of its original amplitude? Let's reuse this equation. Why reuse? Because it's going to be a decay. I need to use the same formula, and c is unknown, but I have found it out here by the initial conditions. Let's try this out. 1,000, so A0 by 1,000 is A0 into e to the power minus c. I do not know the time. A0 goes, so this will just become 1 by 1,000 is equal to 1 by e raised to ct. So e raised to ct is equal to 1,000, of course, logarithmic form. So ln 1,000 is equal to C into T. Fair enough. 1000 is 3 log 10. C is log 2 by 2. So ln 2 by 2 into T. Therefore, T will be, see this, 2 3s are 6. 6 ln 10 by ln 2. Interesting. What's ln 10? You should know this value. Log of 10 is roughly 2.303 and this is 0.6, correct? 67.69 approximately over there. Now this becomes simple to solve. I'll tell you how. Shift the decimals. So this will become 6 into 23. Okay, and here you have 6.7. 6 and 6.7 roughly cancels out, roughly equal, slightly less than 1, that ratio, think about it. 23 into something which is slightly less than 1 will make the final value very close to 23, but slightly less than that. Is there an option like that? Yes, I have it. 20 seconds. Understood what we did? That's the catch. So you don't have to sit and calculate it. You just have to make a small approximation. 6 and 6 point something cancels out. Okay, fair enough. It's going to be slightly less than 1 and slightly less than 1 into 23 will be slightly less than 23. Fair enough, I have an option here. Yeah, there you go. Okay. Sure, Jade, I will definitely consider that. It was anyways on my mind. Okay. Now, next question is coming up on your screen. Two mutually perpendicular SHMs have same amplitude, same frequency. When they superimpose, the resultant form of the vibration will be, come on, this is easy. Same amplitude, same frequency, same phase. What's the answer? Come on, everybody should give a shout out on this. Come on, this is so easy. You should be able to do this. Straightforward. Amplitude is same, perpendicular SHMs. What is the final answer? Come on, my warriors, figure this out. Perpendicular, if they are perpendicular, obviously, it could be either a circle or an ellipse or a straight line. But the catch is, it is in phase, same phase. Hence, it has to be a straight line. No, it is not circle or ellipse. Be careful. It will be a circle. Oops, where did it go? It will be a circle or an ellipse if del phi is not 0 or if it is not pi. It will be straight line because the phase difference is 0 or pi radians. Parabola, it is never a parabola. Keep this in mind, okay? So many students make a mistake in this, and I have seen many students write either a circle or an ellipse, and many people forget that straight line is also a possibility in case of perpendicular SHMs. Next question coming up on your screen, here it is. Period of oscillation of a simple pendulum which is on the roof of a vehicle which is going down on an inclined plane without any friction, that means it is smooth, is how much? Let me draw the diagram for you so that you get an idea of what exactly is happening. So there is this room over here, and maybe you can show some rollers. It's sliding down an inclined plane, and you have this beautiful little, you have this beautiful pendulum which is performing oscillations. The question is, what is the time period of oscillation? First thing, because it is inclined plane and there is no friction, can you quickly tell me what should be the acceleration of this trolley, this bus or cart or whatever, okay, roof of a vehicle? What's the acceleration? Come on, put it up in the chat box. I want to see whether you know this. Basic 11th standard physics, Newton's laws of motion. Anything which is sliding down an inclined plane, left freely, what is the acceleration of that? Obviously, g sine theta. No, tan. Where is tan coming from? Sine. It's g sine theta. Cool. Remember, whenever you have pendulums in accelerated frames, do consider the pseudo force. Apart from the weight, do consider the pseudo force. Now, for this entire system inside, okay, please come here. Okay. Now, for this entire system inside, think what are the forces acting. One is obviously the weight, and next is the pseudo force. Weight and pseudo force for anything which is inside that box in that vehicle. pseudo force will be mg sine theta. Makes sense? M into acceleration of that frame. It's going to act that way. Gravity's weight can be split into two components, correct? Up. So this is one thing. So you can have two components, one component here and one component here. Obviously this is theta, so this would be mg cos theta and this would be mg sine theta. Pseudo force mg sine theta. Gravity's component down, mg sine theta. Gravity's component perpendicular, mg cos theta. Can you guess and tell me what's the net force? Add these solid lines. Mg sine and mg sine will cancel. Don't you see these two are equal forces? Would they cancel? So what will be the net force? What will be the net force? The net force will be just, it will be just mg cos theta. Got it? It's just mg cos theta. Now that's the crux of the problem. Once you understand this, realize that the pendulum in the equilibrium position will try to stay here. This is its equilibrium position. This is its equilibrium position. From this position, it's going to oscillate. So if you suspend that pendulum which is falling down from a trolley which is freely moving on this smooth plane, the equilibrium position is like this, not like this. It's like that. From that it will oscillate like this. So for that guy, for that pendulum, the time period which is 2 pi under root L, G is not G, G is G cos theta. So this is the time period. It feels, for it feels gravity is G cos theta. Hence the answer should be, is it there somewhere? Yes, that's the answer. Option A. Brilliant question. Okay. Oh my god, we are dealing with alpha and not theta. Oh yeah, Devesh, that's trivial. I mean, the concept of the problem is all about pseudo force. Nobody cares whether it's alpha, theta, beta, gamma, psi, pi, phi. It doesn't matter. It's okay. Bhavna. The essence of the problem is all about pseudo forces over here. That's true. I'm so glad you guys didn't realize, because that shows that you are completely engrossed in the problem just like me when I'm solving this. Perfect. Great. Let's move to the next question coming up on your screen. This was asked in 2009. There is a rod, it's hinged, two springs, constant K. You rotate it, leave it, it oscillates. Beautiful question, and let's see how to solve this. Okay, so let's see what is happening. I wouldn't want to use that diagram. Let me draw a fresh diagram. Let's say that rod which is there, if I tilt it, it will push that spring, and it will also push this spring. It will end up compressing both the springs. So let's say I tilt it this way. Let's say I tilt it this way. Obviously, this spring will get compressed, and even this spring will get compressed. It is hinged over here. It is hinged over here. Now, how much is the compression? And we need that. You can see that from this point it has compressed this much. Let's say I call this as X, and this is also the compression X. Why do I need it? See, simple logic. Because the springs are compressed, each spring will exert a spring force, F and F. Because of the spring force, there will be a torque like this. This torque will pull that rod back to its original position. So there is a restoring torque the moment you tilt the rod. If you pull it that side, the springs will get extended, elongated, and they will pull back the rod. So that's why it oscillates, because of the restoring torque. Is that making sense to all of you? Okay, cool. Now, the moment you understand there is a restoring torque involved, okay, I'll just put it over here. This is restoring in nature. Obviously, this is an angular SHM problem. So somehow show torque is proportional to theta. You will be wondering what is theta now. Okay, so theta, let me just put it up over here. This from its equilibrium position, this angle or even this angle, that is your theta. Okay, that is your theta. How do I show it is proportional to theta? Let's find this out. Okay, step by step, observe. In this triangle that you see, can you see this part over here? Okay, can you see this part over here? This is x almost, this is theta, and this is L by 2. If the total length of the rod is L, this is L by 2. This is your hinge point. So can I say x is actually L by 2 into theta? Can I say x is L by 2 into theta? Okay. Force is kx. Force, this force is k into x. And x is L by 2 into theta. That means it will be k L by 2 into theta. Got it? Okay. Next step. Observe. Torque will come because of this force and that force. About this point, this force creates clockwise torque and this force also creates clockwise torque. So both the forces act like a couple and they create a torque. And what's the torque? Because of a couple. It's the distance between the two forces into one of the force. Agree? Disagree? Remember coupled torque. Coupled torque is any one force into the distance between them. So this torque is like a coupled torque, and it is obviously the distance between the forces. Just one second. It's nothing but the distance between the forces into any one of the force. The distance between the two forces is L. Any one force is F. That value of the force, I just figured it out. K L by 2 into theta. So this will become K L square by 2 into theta. That's your torque. Once you get this torque, you can clearly see this is proportional to theta. That's what I wanted. Just like F is proportional to X, torque is proportional to theta. So this is like your equivalent constant. And that's it. That solves our problem. Time period is 2 pi under root moment of inertia divided by that constant, whatever you get. In this case, it is, oh, it's a rod at the center, hinged, ml square by 12, of course. So ml square by 12. Constant is k l square by 2. So 2 goes on the top. So this will become 2 pi under root, L square goes, 2 goes with 12. So m by 6k. This is time, but I don't need time. I think I need frequency. So f is 1 by t. So f will be inverse this. So 1 by 2 pi under root 6k divided by m. And I think I should have an option like that right over here in option C. Yes, it is there. Beautiful question. We can assume because it is very small displacement. Yes, very true. If x was not small, if x was large, obviously, think about it, when you move this, the distance between the two forces will also decrease. Obviously, when you rotate it by a large amount, the distance will reduce. So this x has to be small. So that's why it's mentioned clearly over here, small displacement. Very, very important. Okay, cool, great. So that's the answer. So now if you have enjoyed these lectures and if you want more such problem solving sessions, you want more such one shots, but even more detailed form, we have a crash course which is running. There is a crash course, there is a course for 11th and there is also a course for 12th standard students. All you need to do is make sure you are on the right links. So let's say for example, when you're watching this video right now over here, go down to the description box. There is one reason why I tell you always about the Vedantu platform, because students who can manage and study combination of YouTube plus the platform, that's the best combo you can get. Obviously there will be things which will not be done on YouTube, which will be done in the platform, and even vice versa. So the combination works really well. So if you're an 11th standard student, go to the JEE 2-year course. That's you're targeting JEE 2023. It's mains plus advanced. You will get the full syllabus, 11th standard crash course, Tattva material. You will get assignments, test series, mock tests, advanced preparation, BitSat preparation, KVPY preparation, CBSE board preparation, notes, replays, doubt solving, you name it. And the total course price is 53,999. But if you want to try it for 1 month, it's fine. You can save using my discount coupon code. Although it says 15 days, understand, because you have used my coupon code, it will be valid for 1 month. So actual validity is 1 month using 1,350 rupees. So you can revise the entire 11th standard syllabus in this 1 month at just 1,350 rupees. That's a big deal if you are a 11th standard student, because also if you want to continue after 1 month, you will get enrolled into a batch of 12th standard, which is the 11th standard students moving to the 12th standard. And obviously, that momentum builds up and you already know the systems and you are in the first batch which has just crossed from 11 to 12. And similarly, if you are a 12th standard student or a dropper student, click on the other link, class 12, and here you have the JEE 2022 crash course. It has 75 live classes plus many more recorded classes as well, and also all the recordings, PDFs, test series, assignments go as standard. 20 mock tests with all India ranking comparison. It says 9,000, but when you use my coupon code, see what happens. You save 1,000 and you get it for 8,000 bucks. So big deal. It's a very, very interesting offer which you can definitely consider for joining, and making sure that you prepare not just from YouTube or other resources which are available, but also in a systematic, more refined, and with teachers who have consistently produced results. So check this out, and also you get more cashbacks when you use Amazon Pay and MobiWik. So definitely you would want to consider that. Thank you so much, Bachalog, for joining in today. It was lovely to have you guys here, and so make sure that you stay tuned on this channel, and a lot of updates do keep coming. So that's why you should always hit the like and the subscribe button, because that's how our YouTube algorithm works. Take care, Dakshin, Arvinder. So अच्छा हुआ मैं फर्स्ट ईयर में हूँ, ये करना नहीं पड़ेगा. Unofficial Nala, you will have to do it anyways because you are preparing for JEE or NEET, obviously. Okay, so Arvinder, it's not a promotion, bacha. A lot of students do not know about this, number one. Number two, there are students who probably are unhappy with their coaching, or they have not enrolled into coaching. And it's not just, see, when I tell you about these courses, I really feel these courses make a difference, because I am teaching, and not just that, I'm also convinced, and I'm also very sure that there is a big delta, big change that can happen because of these courses. Oh my God, CB, you paid $100 in the super chat. Oh my God, this means a lot. Means a lot. Thank you, Rebecca. Thank you, DSG. You're a NEET aspirant, CB, and you're so happy. You're my fan. Which series of mine will you recommend for NEET? Well, see, bacha, because NEET exam is little bit late, I would suggest you to go with Nurture and Pathfinder series. And once you're done with that, go with my Zero to Hero playlist. That will help you. Okay, bacha? I hope I have answered your question. I'm so happy, bacha. It means a lot. You don't have to, I don't know what else to say. I always love everyone, and I would love to respond to all the chats. But when you do such things, it just blows away my mind, and I don't know. I'm speechless. Thank you so much. Have a great time. Please stay safe and stay tuned on the channel, and also make sure you get in more of your friends on Enthuse, because that will inspire me and motivate me to conduct more such classes. Take care. Hasta la vista. This was Capro Shreyas.